Hello, this is Dr. Ryan Johnson. This is Introduction to Statistics at Grace College, and we're doing section 4.3 today, which is the two standard deviation and theory-based confidence intervals for a single mean. So last section we did for a single proportion, so we're just changing up what type of data we had. So we had categorical, now we have quantitative data. So you should have read through section 4.3, looking at average prices of Honda Civics, and the idea of the confidence interval in the more general sense stays the same of statistic plus or minus a multiplier times standard deviation of statistic. It's just that the equation for this last part is really going to change. So, and a little bit of the multiplier is going to change. So hopefully you're able to identify what is what. I like the phrasing here of like car to car versus sample to sample. That's a good way to kind of think about how these numbers end up being different. So standard deviation is going to be sigma, and then our average of the population is going to be mu, because remember we use Greek letters for the numbers for our parameters, which are usually the numbers we don't know. So then the equation for standard error is going to change to be standard deviation of the sample divided by square root of n. So moving down to here, this is a fairly short section. It's good to, this last thing before the challenge is always good to remember. The confidence interval is about your confidence about where the average is. If you think about picking any random car, it's very likely to still be outside of that confidence interval because there might be a lot of variation in the prices. So even though we could be pretty certain about where the average is, we might not be certain where a particular random one is. So let's turn to our worksheet then. So for our worksheet, we're going back to the sleepless nights or the the hours of sleep of college students. So this was you might want to look back at our class data from section 3.3 for this. So for number one, if mu represents the average number of hours of sleep of all the students at Grace College got the previous night, the question we asked in a previous exploration was, how much sleep to the nearest quarter hour did you get last night? If you still have the data from that exploration, so go and get it, that's section 3.3. For answer these questions about your sample, what is the sample size, what is the average, and what is the standard deviation of that sample? So your data is going to be different from mine, but I have this data right here, and so if you've got your data in a spreadsheet, you can always count 23 down to 2 would be 22 things. So I have n equals 22, and then the mean would equal average of this. So all spreadsheet software have these sorts of functions in them, and then standard deviation would equal standard deviation, and you're going to want the dot s because you're doing standard deviation of a sample, and then you highlight these guys. And that's how you could calculate it if you already have them in a spreadsheet. Or you could go to our link to the applets, which would take you there. And then the one mean applet is a good way to go. So you want to clear this data and then maybe copy this. So Control C, or if you're in a Mac, Command C, and then Control V. If you're in a Mac, it'd be Command V, and then use data. And so I get the same numbers here: the mean, the standard deviation, and the size. Okay. So based on your sample data, what is your best guess or estimate for your value of mu? So your best guess, it's one of those numbers that we just calculated. All right. Okay, number 3. Suppose you repeated the survey by asking a different group of students at your school. Will the average for this new sample be exactly the same as the original sample? Why or why not? keyword for that question is exactly. So you're answering a question that has the word exactly in it. Remember that. Okay. So here again we see the generic formula for confidence interval, which is sample mean plus or minus multiplier. Multiplier is going to be changed based on circumstances. And then standard deviation of the mean, which is going to be a formula. Okay. So then for 95% confidence, multiplier can be 2, as in 2 standard deviations. All right. So in a previous exploration, you simulated the distribution of sample means from this hypothetical population of sleep times. What did you find for the standard deviation of the sampling distribution? Well, if you don't remember, but you have the data, you can always redo it. So let's sampling options, move over here. My sample size 22. Yours might be different. Number of samples, let's do like 1,000. Draw samples, and something not quite right there. Sleep. Okay. Oh, that's because I'm drawing samples of exactly the same size that I have. Let's say I was drawing, that's my population. Okay, this is a great thing to remember when using this app, is that when you do sampling options and if you try to sample the same number of, sample size, if you try to sample the same number as your sample, then you're going to get this strange phenomenon where you take the whole sample every single time. Like when you try to pick 20, there's only one way to pick 22 things from 22 things. So that's why they have this option right here. So if I do this, and then I come over here and reset, and then draw samples, then I get an actual distribution. And so what did you find for the standard deviation of the sampling distribution? So in this case, my standard deviation is this, but your data will be different. Okay, so good use of the app. Remember how to use the app is a key thing there. So there'll be less sample-to-sample variability in the sample mean than the person-person variability in sleep times. So for instance, the person-to-person variability is 1.267 as a standard deviation, but when we're talking samples, we're talking 0.274 of the averages. Okay, so previously we saw that S divided by square root of n could be used to approximate the standard deviation of the sample means. We often refer to such an estimate as a standard deviation of a statistic as a standard error. Report this value. So your numbers will be different from mine, but I'll use mine, 1.267. So 1.267. And then I might need to make this so you can see it better. There we go. All right. And then 1.267 divided by my sample size, which is 22. Take the square root of that. And then I get 0.27, basically 0.27. So I would report that for my answer. Okay. So report that value. So the key idea, an approximate 2 standard deviation method for a 95% confidence interval for population mean is X bar, that's your sample statistic, plus or minus 2 times standard deviation divided by square root of n. This method is valid when the sampling distribution follows a bell-shaped symmetric distribution. And we'll talk about how to know that in a little bit. Okay, so use the value of S over square root of n you found in number 5 and the 2 standard deviation method to approximate a 95% confidence interval for mu in the context of the sleep study. So I would take this number that I found right here, and I would use that, so you take that number, and this is my sample-to-sample variation, time multiplied by 2, and then add and subtract it to from my sample statistic. Okay. So basically following this formula right here. Okay. Hint. Okay. So does the 95% confidence interval reported in number 6 contain 8, the population mean under the original null hypothesis? Explain how you could have known this in advance based on your p-value from previous sleep time exploration. So remember how confidence intervals and p-values are related, in that confidence interval is all of the it's all the null values for a hypothesis where the p-value would be too big, that it'd still be plausible, because a p-value is the probability of knowing that, like assuming the null hypothesis, probability that we'd get the results is extreme. And so when it's really low, then we reject the null hypothesis. But if it's bigger, then we say, well, that's plausible, so we can't reject the null hypothesis. And so this relates to, remember how basically this question number 7 is going back to the idea in 4.1 of how null hypotheses and confidence intervals are related. So remember that. All right, I'm going to take a pause here, and then we're going to do theory-based approach next.